Okay, so let's say you're a dinosaur. It's been a good run, which don't worry, you're gonna be fine because science says dinosaurs didn't go extinct until about 66 million years ago after that asteroid impact. And while the end of the Cretaceous period was definitely pretty rough for a lot of living things on Earth, the asteroid's impact vaporized everything nearby. There are two main types of rocks found at impact sites called suevite and impact breccia. Suevite is made of melted rock and minerals from both the asteroid and the Earth. Impact breccia is made of fragments of rock that were blasted up from the Earth. The asteroid would have blasted tons of particles and sulfur-rich rock into the atmosphere. So even if you managed to survive the heat and the fallen debris, the asteroid's impact may have instantaneously ended life, as it was known in the area surrounding the U. They didn't make it very far into the Paleogen. Their reign had lasted for over 165 million years, and throughout most of that time, they had been the dominant force on Earth. But their time in the sun was fleeting. They noticed a shift in the carbon isotope ratios of the foraminifera from the late Cretaceous to the early. And sure enough, they found that the shift in carbon isotope ratios corresponded closely with the timing of the asteroid impact. But this wasn't the whole story. You see, the amount of carbon-13 in a dead animal depends on what it ate and when it died. But the details of exactly how long and how varied this recovery was are still being debated. We may never know exactly what happened to those dinosaurs in the last 24 hours of their lives. But recent findings suggest that they hung on longer than we once thought. They survived the asteroid impact and the wildfires, the tsunamis, and the ice age, but ultimately, they lost their battle against the bacteria. If it ate lots of plants, it will have a higher carbon-13 signature. And if it died during ecological turmoil, it will also have a high carbon-13 signature. So just seeing a spike in carbon-13 doesn't necessarily mean that there was a mass extinction going on. Normally, you would unsee such a big change like this, unless the climate shifted from mostly land plants to mostly ocean plants. In the fossil record, there is a gap between the last appearance of the dinosaurs and the first appearance of new species in the area. The researchers think that the delay in the ecosystem collapse was global. Other studies have suggested that the dinosaurs went extinct around 300,000 years after the asteroid impact as well. So it looks like this finding fits nicely with other lines of evidence. The researchers calculated that the disappearance of the dinosaurs caused by the asteroid impact likely triggered this gap, and they estimate that it took 300,000 years for the ecosystem to fully recover. But the researchers knew that this wasn't the case. They looked at the geology of the area and found that the habitat was consistent throughout the time they studied, which ruled out any changes in the carbon cycle. That meant that there must have been a disruption in the food chain. Something big must have happened. Scientists used to think that they died out shortly after the asteroid impact, but now it seems like they lasted a little longer than that. But its true legacy would unfold over the next few decades. But it wasn't the end of life on Earth. Instead, it was the end of the Cretaceous, which brought about the start of the. As awful as it was, this asteroid impact paved the way for mammals like our primate ancestors to take over the Earth. After all, there were fewer predators and no competition from dinosaurs. You wouldn't be able to breathe. The dust and gas formed a thick cloud that blocked out the sun. Plants struggled to photosynthesize without sunlight, and animals starved without the plants to eat. Those that didn't freeze to death in the ensuing ice age. Basically, the asteroid killed off everything it touched and everything that depended on the stuff that the asteroid touched. The suevite found at Chicxulub indicates that the asteroid was rich in limestone and clay, while the impact breccia suggests that the ground beneath the asteroid contained a lot of calcium, leaving behind a huge crater that scientists call the Chicxulub crater. At the end, Cretaceous proposed that the Nanavian dinosaurs died out 300,000 years after the asteroid impact. Now, to put that into context, normally when you see a mass extinction, all the species die off at roughly the same time. So the fact that these dinosaurs stuck around for another 300,000 years is like unheard of. Today, it's mostly underwater, but it is still pretty easy to spot thanks to a circular fault line that extends for about 180 kilometers. This type of rock forms from layers of mud that accumulate on the bottom of lakes and oceans. Because it forms in water, it traps a lot of dissolved carbon dioxide from the surrounding environment. So by studying the carbon isotopes in a particular type of microorganism called researchers can learn about what the atmosphere was like when the organism was alive. Isotope analysis can reveal a lot about what was going on in the environment when an organism was alive. For example, carbon-13 is an isotope of carbon. Carbon-14 is unstable and decays into nitrogen-14. But carbon-13 is stable. When organisms take in carbon, they tend to prefer the lighter carbon-12 over the heavier carbon-13. So if there is a higher proportion of carbon-13 in a fossil, that could mean that it died during a period of ecological chaos when the ecosystem was rapidly changing. Scientists were able to date rocks near the crater to figure out how old it was, and the results pointed to an age of 66 million years. Also, they found shocked quartz and tektite deposits, which are only known to form under extreme temperatures and pressures, meaning they are strong evidence that something pretty traumatic happened in the area. Scientists have found that many species, including some dinosaurs, did actually survive the impact, at least for a while. But they might not have made it out alive after all. They affect the whole planet. In the immediate aftermath, the shock wave from the impact rippled across the globe, triggering giant landslides, earthquakes, and massive tsunamis. But the tsunami generated by the impact was only the beginning. The wave had an estimated height of about 100 meters, which makes sense given that the asteroid itself was between 6 and 9 miles wide. Within hours, these waves would have circled the entire globe multiple times. They would have inundated coastal areas, reshaped coastlines, and deposited vast amounts of debris into the ocean. These giant waves wiped out any life within reach, whether it was on land or in the water. You've lived for tens of millions of years and have spent your whole life sunning yourself on the shores of the Cretaceous Sea. You see, most of the earth-shattering asteroid movies have a pretty similar plot. A space rock comes hurtling toward Earth and completely obliterates everything upon impact. But the real-life consequences of an asteroid impact are as straightforward as that Hollywood ending would have you believe. Most of the major damage is actually done after the initial impact. Immediately after the collision, the energy from the impact would have heated the surface of the Earth to thousands of degrees. This intense heat would have incinerated everything within hundreds of kilometers of the impact site, killing off anything that hadn't already been wiped out by the tsunami. But further away, wildfires would rage as the heat ignited dry vegetation. Hot debris rained down from the sky, burning fields and forests to the ground. Okay, you probably already know this story, but just in case you don't, here's a refresher. About 66 million years ago, Earth was hit by a large asteroid or comet. It landed in what is now the Yucatan Peninsula in Mexico. Its impact triggered earthquakes, tsunamis, and a massive release of climate-changing gases. It also kicked up so much dust into the atmosphere that sunlight couldn't make it through, and our entire planet went into a decade-long ice age, happily munching on marine algae. Life is good, but today something feels different. The air is thick with an unnatural stiff. There isn't a cloud in the sky and it's hot, like really hot. You know, it's one of those days where if you were a bird, you would totally be migrating right now. Except you aren't a bird, you're a dinosaur. So you keep on happily munching your algae, except then some dumb bird shows up and tells you that there's a giant flaming rock hurtling towards Earth. First, let's talk about what actually happened 66 million years ago. Now, we do need to address the whole dinosaurs are birds thing, because when people hear this, they get super confused. Like, hey, if birds are dinosaurs, then how come birds weren't affected by the asteroid impact that killed all the dinosaurs? To answer this question, we have to think like a scientist. That means looking at the evidence instead of relying on our intuition. Our intuition tells us that birds are kind of like modern-day dinosaurs. so they should have died along with all the others. But look at the fossil record. Birds first appeared during the Jurassic period over 200 million years ago. Well before the asteroid impact had marked the end of the Cretaceous, they evolved from theropod dinosaurs like Velociraptor, and they continued to show up in the fossil record after the asteroid impact. So birds definitely evolved from dinosaurs, but they were around long before dinosaurs came onto the scene. And they're still around today because they had already evolved to fill a bunch of ecological niches. If they disappeared, there would be way more extinctions. Okay, back to the Yucatan. And we can tell what part of the asteroid actually hit the Earth. But impacts don't just affect the area directly below them. When it comes to the effects on the climate, though, things get a little more complicated. And then the skies got dark. Within weeks of the impact, the world was unrecognizable. As for the dinosaurs that did manage to survive the impact, a paper published in 2022 by the title of Delayed Terrestrial Ecosystem Collapse in order to get to this conclusion. The authors of the study looked at a carbon isotope record from a sedimentary rock called shale. When the team analyzed the fossils they collected, the researchers wanted to narrow it down further, so they dated the layers of shale that they were working with. So the researchers turned to the fossil record to confirm that this was, in fact, a mass extinction. Now, while this study was focused on a specific geographic area, basically, what we're seeing here is an ecosystem that took a long time to recover from the asteroid impact. Longer than we previously thought.